Good morning, dear students. Myself, Harish Dwivedi, Assistant Professor, Institute of Engineering and Science, IPS Academy, Indore. Today I cover unit number 4, Sewage Scheme and their importance, Environmental Engineering. Introduction. Sewage are expensive to conduct and if not built correctly, remedial works, time consuming, costly, and in some circumstances have adverse effects on a company reputations. This is an on-site guide for contractors and operative constructing sewers with advice notes provided to avoid some of common on-site errors. Mainly, sewage importance is the sewers are extremely important components of urban infrastructure that helps keep the urban environment safe from flooding and prevents the spread of waterborne diseases by safely transporting wastewater to the water treatment works and through the transport of rainwater from urban surfaces. Types of sewage includes sanitary sewers used slowly for carrying sewage, surface water sewer used to drain groundwater and excess water from impervious surface, combined sewer used to carry both sewage and surface water. This type of sewer can lead to water pollution problems when overflow conditions are experienced. Effluent water to as the septic tank, effluent drainage STED, or solid free sewers. These collect remaining sewer from septic tanks and carry it to a treatment plants. Sewer are correctly expensive to construct and if not built correctly, remedial works can be disruptive, time consuming, costly, and some circumstances have adverse effect on companies' reputations. Sewer for adoption contains guidance for the design and construction of sewer that will be adopted by sewage undertakes. These are 4 types of collection system. Pehla, separate sewers, second combined sewer, third one is pressurized sewers, and last one is vacuum sewers. First one is separate sewers. These sewers receive domestic sewage and such industrial wastage pre-treated to the discharge standard as per the Environmental Protection Act 1986. Second one is combined sewer. This sewer receives storm water in additions and have some advantages in location of intermittent rainfall almost throughout the year and with the terrain permission. Gravitated collection and obviously being confined to a carry very small region as a whole. As otherwise in regions of seasonal rainfall like in monsoons, the combined system will have serious problem in achieving self-cleaning velocities during dry season and necessitating complicated egg-shaped sewer, etc. Third one is pressurized sewer. Pressurized sewer are the collecting sewer from multiple sources to deliver to an existing collecting sewers and to the STP and are not dependent on gravity and thus topography is not a challenge. The principle of advantages are the ability to sewer area with undulating terrain, rocky soil conditions and high groundwater tables are pressurized sewer can be laid close to the ground and well besides there cannot be infiltration is quickly detected and set right and essentially smaller diameter pipes. And last one is vacuum sewer systems. The vacuum sewer collects sewer from multiple sources and conveys it to STP. As the name suggests, a vacuum is maintained in the collection system and when a house sewer is open to atmospheric pressure, sewage and air are pulled into the sewer, whereby the air forms a plug in the line and air pressure pushes the sewage towards the vacuum stations. Next topic, shape and sizes of sewer. We know the sewer is various types of shape and sizes. First one is the introduction, discuss about The introduction. Introduction factors influencing the selection of material for sewage are flow characteristics, availability in the size required, including fitting and case of handling and installations, water tightness and simplicity of assembly, physical strength, resistance to acids, alkalis, gases, solvents, etc. Resistance to score, durability and cost, including handling and installation. No single material will meet all the conditions that may be encountered in sewer design. First one is brickwork. Brickwork of sewer. Brickwork is used for construction of sewers, particularly in the larger diameter. Many old bricks sewer are still in use, and the failure are mainly due to the disintegrations of the bricks, the mortar joints. Because of the comparatively high cost, larger space requirements, slower progress of work, and other factors, brick is now used for sewer constructions only in special cases. The advantages of bricks sewer is that these could be constructed to any required shape and sizes. Brick sewers shall have cement concrete and 12.5 mm thick cement plaster with neat finish for the remaining surfaces. Second one is concrete. The advantage of concrete pipes are the relative case with which the required strength may be provided, feasibility of adopting a wide range of pipe sizes, and the rapidly with which the trench may be backfilled. However, these pipes are subject to crown corrosion by sulfide gas, mid-depth water line corrosion by sulfate, and outside by sulfate from soil water. These shall be manufactured with sulfate resistant cement and with high alumina coating on the inside at the manufacturers. Protective measures at outline in corrosion protection in sewers shall be provided where excessive corrosion is likely to occur. Third one, precast concrete. Plain cement concrete pipes are used in sewer system on a limited scale only, and generally reinforced concrete pipes are used. Non-pressure pipes are used for gravity flow, and pressure pipes are used for force mains, submerged outfall, inverted siphon, and for gravity sewers. Non-pressure pipes used for construction of sewers and culverts shall conform to the IS 458. Certain heavy-duty pipes that are not specified in IS 458 should conform to other approved standards. Cast iron pipes and fittings are being manufactured in the country for several years. These pipes are available in diameters from 80 mm to 1050 mm and are covered with protective coating. Pipes are supplied in 3.66 meter and 5.5 meter lengths. Fiberglass reinforced plastic pipes. These pipes is matrix or composite of glass fiber, polyester and filters. These pipes possess better strength, durability, high tensile strength, low density, and are highly corrosion resistant. These pipes are manufactured in diameter up to 2400 mm and length up to 18 meter. These pipes are now being taken up for manufacturer in India. Further, the following factors must be carefully considered in sewer. First one is hydraulic efficiency. Hydraulic efficiency is the material selected should be such that value of Manning's coefficient N is as low as possible so that a hydraulically efficient surface is available. Second, resistance The following sewers may contain a lot of solids such as grit and sand particles. At a high velocity, at the sewage invert, erosion of sewer material may take place due to abrasions. For a longer life, the sewer material must possess high degree of resistance to abrasions. Third one is resistance to corrosion. The composition of sewage may be such that the sewer material may get corroded for longer life. The sewer material may get corroded for longer life. Sewer material should be possess enough resistance to corrosion. Strength. The sewer are generally laid underground and hence they are subjected to a number of external forces including the weight of overburden and the life loads. Material should be material should of strong enough to resist all such external forces. Durability. The sewer material should be durable so that expenditure due to its frequent replacement is minimal. Next, cost. The cost of the material should be lost so that overall economy is minimum. Weight. The material should be light in weight so that it can be easily handled. Imperviousness. The sewer material should be impervious and should not allow sewage of the from the sewer. Manholes. There are several types of manholes. Manholes are masonry or RCC chamber constructed at suitable intervals along the sewer lines for providing access into them. Manholes are classified as follows, that is, first one is shallow manhole, second one is normal manhole, and third one is deep manhole. First one is shallow manhole. It is about 0.7 meter and 0.9 meter depth. It is constructed at the start of a branch sewer or at places which are not subjected to heavy traffic. Such a manhole is provided with a light cover at its top and it's called inspection chamber. Last, generally these types of manholes are provided at the domestic areas. Second one is deep manhole. It is having depth for more than 1.5 meter. The selection of such manhole is generally not kept the same. The size in the upper portion is reduced by providing an offsets, steps, etc. are providing in such manhole for facility descending into the manhole and to enable to the workers to go up into its bottom. This is the manhole cover, RCC slab, steps, wall, branch sewers, benching, branch sewers, and offsets, access shafts. This is the manhole. Drop manhole. The manhole is which a vertical pipes is used called a drop manhole. When a branch sewer enters manhole by more than 0.5 meter and 0.6 meter above the main sewer, the sewage is generally not allowed to fall into the manhole. This is the drop manhole. This is the depth and width of drop manhole. Inspections are branch sewer, vertical pipes to connect working chamber, these two steps, and centrally core is main sewers, and bottom is the fill to the concrete. Clean outs. A clean out is an inclined pipe exceeding from the ground and connected to the underground sewer. It is used for cleaning sewer pipes. This diagram is showing clean outs, removal covers under the ground surface, above the ground surface, and under the ground surface flows the sewer and drain pipes. Elbow is fit in 45-degree inclinations. Street outlets. Street outlets are opening on the road surface at the lowest point for draining rainwater runoff from the roads and admitting it into the underground stormwater sewers. There are two types of state inlets, vertical inlets and horizontal inlets. Pumping. Problem in sewage pumpings. It is the main or big problem of sewage system. The pumping of sewage is not as simple as pumping of water, since the following special problems are to be faced in sewage pumping. First one, sewage has foul characteristics. Second one, sewage contains a lot suspended and floating material. These may make the running and pump difficult to may cause frequent clogging of the pump. Third one is sewage contains organic and inorganic waste which may cause erosion, corrosion and erosion of part of the pump and the reduced lifts of the pumps. This diagram is showing the pump outlets. Pumping stations. Location of pumping stations. It is the proper location of pumping stations required as a comprehensive study of the local area to be served and ensure that the entire area can be adequately drained. If a very large quantity of sewage is to be pumped, the site should be near a stream or stormwater drain into which is the sewage could be discharged during emergencies, such a breakdown of the pumping plant. If this precaution is not taken, the station should be located and constructed in such manner that it will not be flooded at any time. Further elements of pumping stations. Apart from the structure of the pump house, a sewage pumping stations consist of the following elements. First one, grid chamber. Second one, coarse and fine screens. Third one, sump well or wet well. Fourth one, pump room or dry well. Fifth one, pumps. Sixth, miscellaneous accessories such as pipes, valves, float, switches, arrangements, float switching arrangements, flow recorders, emergency overflows, ventilation arrangements such as extraction fan, etc. Pumping stations. First one is dry well, wet well, rising main, pump used. Dry well for housing the pumps is used to house. Wet well for incoming sewage. Third one, rising well to let the pumped sewage to high leveled gravity sewer. Pump used generally in sewers. Yes, STP plants, we used two or three types of pumps: centrifugal pump, reciprocating pump, propeller of axial flow, and air pressure pumps or ejectors. Elements of pumping stations. Pump house structure. The pump house structure should be designed to withstand flotation forces to which it may be subjected. The substructure of the pumping station may be of mass concrete or RCC, while the superstructure may be constructed of any material. The internal walls and floors should be structurally, structurally designed to take the weight of machine along with the live load of 5 kilonewton per meter square. The building should be planned and designed keeping in view the requirements. There should be enough scope for future expansions. This diagram is the pump house structure. This picture is showing working pump house structure. Second one is grid chamber. The sewage entire into a pumping stations contains a lot of solid matter such as grit, rakes, sticks, faces, etc. All of which is in suspension as long as the sewage is flowing. It is therefore essential to remove as much of this matter as possible before pumping so as to minimize the wear and tear of the pump impeller and the rising main. The grit is separated from the sewage by the provision of grit and detritus pit before or after the screens. A grid channel is a long basin with enlarged cross sections. This results in the reduction of velocity of flow to 0.15 to 0.3 meter per second. This diagram is grid chamber showing the inlet to collect the grid chamber in grid particles, compressed air, optional, and fats, oil, and gases, greases, and then outlet. Screens. After the removal of grit from the sewage, it is made to pass through the screens to trap the floating matter such as racks, sticks, papers, and many types of raw materials, etc. It is necessary to remove these, otherwise they choke and damage the pump. Screens are two types. Screens are basically two types: coarse screen and fine screen. In large installations, it is usual to provide both, the coarse screen being the first to intercept the flow. Coarse screen is made up of rough iron, rough iron bars kept parallel to each other and having a clear spacing of 50 to 100 mm in between them of coarse and fine screen. This diagram is showing the screening. It is showing the coarse particle of removing the coarse screening, and then minor particle is going to and filter the fine screening. Rising main and valve and fittings. The pumped sewage is led to high leveled gravity sewer through rising mains. The length of the discharge pipe should be kept as small as possible because long detention of sewage in closed pipes under pressure causes their anaerobic deterioration. As far as possible, rising mains should rise steadily from the pumping stations to the point of discharge. The velocity of flow in the rising main should not be less than 0.75 meter per second. At the same time, velocities higher than 2 meter per second should be avoided. That means the velocity of rising main is minimum speed 0.75 meter per second and to maximum speed is 2 meter per second. This diagram is showing the rising main valves and fittings. Next, check valve and gate valves. This diagram is showing the check valve and gate valves. Power for pumps. Power for the operation of pump can be supplied by use of the followings. First one is steam engine, second one internal combustion engine, and third one is electric motor. Thank you so much, students. And in briefly, please study the book Environmental Engineering, Water Supply Engineering by B.C. Punamiya and Sewage System Design by G.S. Birde. Thank you so much and good luck.